and welcome to the introduction for your first official higher experiment that you guys are going to take responsibility for. It's going to include all the skills that we've been learning up to this point: drawing an appropriate data table, recording your reading uncertainties, calculating random uncertainties, and using those digital graphing skills that we've been learning about. So let me show you how we're going to set this up and what the experiment is. And you're actually going to conduct this experiment at home with any object that you can safely drop. Okay? Right, so the experiment, and I'm just going to give it a kind of pithy title, and then the aim will be a little bit more experiment. But basically what we're doing is finding G. There are so many ways to do this, but I would say this is probably the simplest way and definitely the one that's most guaranteed to be able to do at home. So our aim is to find the acceleration due to gravity on Earth. Okay, now I'm going to use a little bit of initial analysis to show you how we're going to do that. Okay. Because like I say, there are lots of ways to do it. Pendulums, springs, Newton balances. Pendulums are pretty easy to do at home, but springs and Newton balances can be pretty tough to come by. We are going to use this relationship. The equation of motion, S equals ut plus a half, sorry, I'm just going to get rid of my bottle, it's shaking away there, half at squared. Okay, and you are going to drop a ball, measure its height of drop and the time it takes to fall. Now let's see how that is going to allow you to find the acceleration due to gravity. So this right here for a fall, that is the acceleration due to gravity. Okay, and for a fall, this equals 0. So that gives us S equals a half at squared, and we want to find A. Well, if we put this in the form of a straight line equation. So if we were to do a graph of y equals mx plus c, we can actually put that equation into that format. Okay, so y is s equals a half a t squared plus 0. That allows this to be on our y-axis, this is our x-axis, and this would be our gradient m. So all I need to do is record data where I've got s in meters, t squared in seconds squared, and plot that graph. Now don't forget, to have t squared in your graph, you must first have a t squared column in your table. So that would be a final column. You'd have your repeats of t, your average, your random uncertainty, and then finally a separate t squared column. So a value being plotted on your graph must first be in your data table, and it can be all in that one data table, but it must be there first. watch your significant figures when you process those numbers. Okay? So going forward, folks, you are going to take, we call this the drop ball experiment. Okay? We're going to take any object that we can drop, ideally a ball, but literally anything you can safely drop over and over and over and over again, and something that's heavy enough to actually fall with the acceleration due to gravity. So like a balloon, for example, wouldn't be appropriate. You just take a ball and you let it drop to the ground. So that is your distance S, okay? You time the drop, and that is all you will need to carry out this experiment. To measure the height, ideally you would use a tape measure. I hope you've got that at home. If you're really struggling for that, you could use something of known length and just kind of do multiples of that. So that, you know, your drop heights don't have to be nice numbers. That, you know, it could literally be like, you know, 1.42 meters and then, you know, or, you know, fractions of that or whatever, just anything of known height, so that you can get some rough distances. Okay, but a tape measure is obviously the best thing. I doubt we've got meter sticks sitting at home. So I don't want to go any further with this because now you are going to use the skills you've been learning. So you're going to construct your data table, you are going to graph your data, you're going to draw a conclusion, and you're going to draw an evaluation. So those are the things I want you to practice with this specific experiment. Okay, so it's over to you to do your data table, graph, conclusion, and evaluation. Okay, so you do yours, I'll do mine, and we can compare answers in, well, quite a while. I think this one's going to take you a while. Please try and use all of the attention to detail that we've been looking at over this series. Ideally, your data table and graph could be digital. I think that would be the best way of doing them. So on Google Sheets or any other spreadsheet programs are available. Or your data table can be manual, but then you have to actually plug the numbers into Google Sheets anyway to get a graph. So obviously doing graphs at home can be quite tough. We often don't have access to graph paper. So I'd really recommend you using that graph tutorial that's in the previous part of this series to do a digital graph. You could then, for your conclusion and evaluation, you could pop those into a Google Doc and simply input the table and graph into that document so it's all there together. So take your time, everyone. Good luck, and I'll see you in a while when we'll be looking at some examples of this work. Thanks, folks.